regarding the production in the short run, we know that actually we have the production function. Okay, so this is from the mathematical perspective, we have the production function. And then second is that, that we cannot change everything. We might increase the hiring more employees, but we cannot change the facility, or we cannot enlarge or increase the space, the size of our operation. So imagine that we have let's say that running a pizza business. 20 years ago, like I was studying in the Santa Fe, and at the same time I was like a teppanyaki chef, okay, or you call this hibachi chef, right? So hibachi chef in a Japanese steakhouse. In total, we have 4 shifts in order to produce the the meals. Then that we need something like the gas, right, the labor, the capital, right, to run or to rent the let's say that to rent the restaurant. Okay, although technology or entrepreneurship maybe not that important, but anyway, those are all the inputs we needed to take into consideration to this the production. Although that the production function can be a function of all those inputs, but I just assume that we have very simple one for that the Japanese steakhouse, which is the labor and then the capital. Okay, so the labor capital, this capital, simply speaking, is the equipment, or this or let's say that the restaurant itself is the facility. Okay, the L and K. So usually we simplify the production function into the Q equal to a function of L and K. In the short run, we know that we have the fixed input, which is the restaurant itself. It has, I forgot, it has like 5 or 6 tables. Let's say 5 tables, 4 chefs. Chef is the variable input, because in this case, like we have 4 chefs. 3 of those are like the owner is also the chef, but usually there are 3 chefs rotating on those 5 tables. So this is the labor, okay? And then the fixed input, as I said, let's keep it simple, it's the table, 5 tables. So we needed to produce the meals based upon the consumption, based upon the demand. So although that in this case, we don't see that somewhere, but when we talk about maximize our profit, we will need to somehow take that into consideration. In this case, we only talk about the production function, which is a function of L and K. The short run means that we have some factors fixed. In the long run, we have all factors flexible or variable. We can change that. That's the only difference. So in the Japanese steakhouse example, as you can see that what can be changed all the time. In the short run, the labor can be changed, right? The tables, the iron tables, they cannot change. 5 tables into that restaurant, you cannot, have the additional tables outside. But in the long run, for example, if the business is good, and then that the owner very likely he will purchase or he will rent another facility, another restaurant, and then build up more tables. That means that the business is expanding, and then that they are flexible to have more tables. Again, that this is now we get into that the short run example, the production, the short run. So generally speaking, if we compare this to our consumption, that we are talking about that the utility function. Right? In this case, we are talking about the production function. They're similar. In the utility function, we consume 2 goods. But in this case, the production function, we also consume. We consume 2 inputs, the labor and then the capital. Okay, the capital is the iron table, labor is the chef, in my example. In this case, it's short run. K, which is the capital, or you call this is the fixed input. It's a constant. Labor is the one that we can change. Remember, we have the marginal utility, the diminishing marginal utility. Remember that, right? In this case, we have the marginal production or the marginal product. And then we also have the law of diminishing marginal product. Actually, it's products or the productions, not the productivity. But anyway, you know the idea behind. Put this together, we call this a diminishing marginal benefits. Okay, the benefits can be the utility, the benefits can be the production. But this is more like the idea is telling you Once we produce more, the additional benefits, or in this case, the additional production is in a reduced rate. For example, we have 3 shifts running on 5 tables. Their productivity probably is increasing. But if I adding me as the 4th shift, it's still okay, right? But just imagine if we have 10 shifts running on those 5 tables, then will be 5 of those shifts are waiting. The marginal production is in a very low level or even negative level. From the mathematical perspective, the marginal production equal to, actually this is the delta total production divided by the delta labor. In this case, we're talking about the labor, right? So in this case, yeah, they are talking about the productivity. It's correct. In general, that we're not specifically talk about the labor. We can talk about any input. So this is the diminishing marginal production. This takes the calculus or the derivative into consideration, but I just try to keep it simple. This is additional production on additional unit of labor. It's not the average, but it's the additional unit. I use the diagram. You can see that this is it's the labor, right? This is the labor. So we're talking about labor. This is the number of trees. So this is the quantity. Total production is increase, okay? Increase, but at a reducing rate. If we take the derivative and then we see this is the marginal, actually this is the MP, the marginal production of the product. Like the Japanese steakhouse, if we hire only one chef, he will be very, very busy. But 2 or 3, we might hit the top. This is the maximized or maximal marginal productivity. But after 3 or 4 shifts, then it is decreasing. Okay, use the graph. You understand what we are talking about. What we talk about the diminution. The above diagram show you the total production. It's increased, but at a reducing rate. But this is the marginal product. It's reduced. Actually, most of the time it's reduced. Give you some real example. I think this is the same thing. This is the production. We already know the production. There is the production function with one variable cost, which is the labor. We have the capital. K is fixed. Okay, keep that in mind in the short run. The cost in the short run, we have those, we call it the variable cost. Actually, we already mentioned that. We have all sorts of factors, inputs, right? Those are all can be the cost, but they are like a variable cost and a fixed cost. Keep that in mind that in the short run, we have only the labor as the variable cost, okay? All other things are fixed. We fix the rent of the building, we fix the tables, right? We fix all other things because of the short run. Like the total cost, including the fixed cost and then the variable cost. This is what I want to say. But just keep that in mind. Later on, we might use the acronym, like the VC stands for the variable cost, TC stands for the total cost, FC stands for the fixed cost. You need to be comfortable with those, those initials. That because we have talked about the production, but in this case, we talk about the cost. The cost function is simple. The cost function is very similar to the budget constraint. You have a constant term, right? This is the fixed cost plus what? Plus the labor we use. The labor times the wage is the variable cost. If we have another variable cost, for example, we call it the capital or the machines equipment. If it is flexible or it is variable, then we have the number of those equipment times the cost of each of those equipment. Remember, this is become a straight line again. And somehow you can relate it to the consumer theory with this the production theory together, right? So because they are more like the same, but they are maximizing different things. The utility is more like for your individual decision, right? But the production, or let's say that it's for a business decision. This is extremely useful if you are a owner of a small business, if you are a manager, but you need to make the production decision based upon those theories. You have to understand your production I mean, although it's not explicitly telling you what is the function behind, but you need to know that. There are, the costs behind that. You also needed to know that what is the cost structure, what is your fixed cost in the short run, what is the variable cost in the short run, and then also in the long run, what is your cost? In the long run, we say no fixed cost. Everything is, like a variable cost. The average total cost, remember that we have the total cost. We already mentioned about the total cost. This can be a function as well. But if we are talking about the average cost, this is the total cost divided by the quantity produced, okay? The Q, the big Q, okay? And then also there is the marginal cost. The marginal cost is a very, very important, let's say that the term that we need to understand. And then this is the delta of total cost divided by the delta of the quantity. Simply speaking, this is additional cost when we produce additional product. Remember the diminution of marginal benefits, but in this case is the increasing, it's not diminishing, it's increasing marginal cost. You produce additional thing, this will cost you more. The different idea, it's increasing marginal cost. So the average variable cost is simply that usually we call this AVC. AVC equal to, what is that? The total, we call it the variable cost, divided by what? Divided by the Q, okay? So this is the idea. Let me move on. As we mentioned that the total cost, so the total cost, keep that in mind, this is like a amount, okay? We just put them together. So even if like our output is zero, keep that in mind, even if our output is zero, because of we have those so-called the fixed costs, the rental, right? The machine, okay? Those tables, I call it the iron tables. Then we have to bear this fixed cost, okay? Even if we don't produce any of the output. But later on, the cost is, you see this cost is increase. This is what I call it the increasing marginal cost. Because that once you have, and then this is in a increasing rate, right? Increase is because we have more production, more output. But at a increasing rate is because of this increasing marginal cost. And this is the opposite to the diminution of marginal benefits. So then this is a quite important diagram that we needed to understand. We put all those costs together, the diagram to show you a average total cost, the ATC, okay? So the ATC is decreasing and then increasing. It's more like a U-shaped curve. Okay, so this is also the same as the AVC, the average variable cost, right? Because this is divided by the quantity, by the Q. Then divided by Q, we will have the decreasing at the very beginning because we dilute the fixed cost. And then it's increasing because end up with like the increased marginal cost. The marginal cost is the line to, how to say, go across this, okay? The idea is you treated the marginal cost is something like to drive the average cost, okay? So the marginal cost drives all the average cost. The marginal cost at the beginning is very low. It's below all the average cost. So it pulls down those average costs. So then it crosses this. So this must be the minimum of the average cost, average variable cost, or the average total cost, okay? So the idea is that the marginal cost drives those, but once the marginal cost above those average cost curve, then it's become like you just imagine a string that pull up. At the beginning, it's pull down. After cross that the average cost curve, it's pull up, okay? Pull up all the costs. So that's why I say that this interaction points are definitely the lowest of both average cost curve. Average cost curve, both are like a U shape. But the marginal cost is more like upward sloping curve. I mean, don't argue with me because there are like a different, if we are use mathematical, let's say approach, and then you can, this can be, let's say proved. This actually, I should save this later because this is the average profit. But just keep this in mind. The profit is the revenue minus the cost, right? So the average profit is the average, or we call that the profit margin, average profit or profit margin. Okay, so this is the term we need. Equal to the price. Actually, price is the average revenue, right? The average revenue. Okay, so the total revenue divided by the Q is the average revenue, and then minus the average cost. The average cost is what? The total cost divided by the Q. You are making profit once the price is greater than the average cost. But if it is, less than the average cost, that means you are losing money. You are not making profit. It's losing money. Then the question here is that you need to make a decision: keep producing or stop producing, or even close your business, shut down your business. But we will mention that in the module 3. All right, let me take a break here.